Hello class. In this lesson we're going to learn about perpendicular bisectors and how to construct them. So let's get to some vocab first that's going to be necessary for this topic. Right angle, very simple definition, has a measurement of 90 degrees. Something to know is that when we have a right angle, we usually label it using a little square, and if it's in color, it's almost always red. You don't use that square for any other degree measure but 90. And perpendicular is intertwined with right angle. When you have perpendicular lines, then you have four right angles where they intersect. Now, it's really only necessary to show one of them is a right angle when they're perpendicular, because we're going to learn some properties of angles, you might already know them, that shows that the other three must also be 90 degrees. So we don't usually draw four boxes, just one little square for perpendicular or right angle. And equidistant. Equal, distant, distance. So they, two segments, we're talking about points here. We're saying that point is equidistant from two other ones if those distances are the same. Now, what do you notice here? What do you think we could draw through B and C, where A would be in the middle? What shape would that be? Well, hopefully you're thinking back to the definition of a circle, because on a circle, every point on it is equidistant from the center. And so AC and AB are actually radii of a circle. And perpendicular bisector, put together the notion of perpendicular and bisector. So we're talking about a segment now. So a bisector is going to cut it in the middle. So each half has the same length. But it's also going to be perpendicular, so it's going to form a 90-degree angle there. So we could have a bisector that hits it not at 90 degrees. So this one would not be a perpendicular bisector in green. So we're looking for something like line CP. And how do we make it? Well, here's the process. So write down the steps in your own words, and then I'll show you the steps from the book. Zoom out here a little bit. There we go. So it starts off very similar to the equilateral triangle construction. You're going to put the pivot on one endpoint, and you're going to open up your compass to the other endpoints. And you're going to draw a circle. So there we go. Now you're going to take your compass, get rid of those, and without changing its size, put it on the other endpoints. And draw another circle. There we go. And oops, let's label those intersection points as C and D. Now, when we did the equilateral triangle, we picked one of these two and we just drew a triangle. But in this case, we actually want to bisect it. So we're going to draw a line through C and D. And this is our perpendicular bisector. And so let's call this midpoint over here M. And let's verify a few facts about it. So both sides should have the same, I'm sorry, not both sides. Both segments we have should have the same length, AM and BM, and we should have a 90-degree angle here. So if we take a ruler and put it on A, let's see, it's AM is 4 centimeters and MB is also 4 centimeters because the whole thing is 8. So we know that's bisected for measurements, and if it's perpendicular, put the middle of your protractor on M, and we get 90 degrees exactly. So that worked out. And here are the steps, and compare them with yours. So make sure you have a diagram of this and the steps in your own words, or these, the way it's phrased in the book, in your notes. So there's a special fact about perpendicular bisectors. So let's look at it. If we take any point on a perpendicular bisector and measure the distance from that point to the endpoints, so from C to B and C to A, what do we get? So we get 7 here, and we get 7 over here. Now, is that a coincidence? I don't know, let's check some more. Well, if we check A, D, and B, D, we get 5 for each, and A, E, and B, E, we get 3.5. And while it's not proof of it, the observation here is correct. It ends up that any point is going to be equidistant from the endpoints of that line segment. So that's a very important fact of perpendicular bisectors. So let's extend what we were doing one more step. Let's pick a point, and we want to draw a line perpendicular through it. I'm sorry, a line perpendicular to a line that goes through that point. That's what we want to do. So we already know how to make a perpendicular bisector, but we need a segment for that. We don't have a segment. Well, how can we make it? Well, if we take A and make that the center of a circle, we can make the circle big enough that it will cross our line 2 times. And we just learned that any point on a perpendicular bisector is equidistant from the endpoints of the segments. And if we label these 2 points right here, B and C, since A was the center of that circle, and A is equidistant from B and C, since A, B, and AC are radii, A must be on the perpendicular bisector. That's what we're getting at here. And so now we're just going to do perpendicular bisector like we did before with B and C, and then connects to A. So let's see, if I put that on C, go over a little bit, draw a circle, flip that around, put it over on C, don't change how big it is. And so now, if we label point of intersection, let's just label the one on the bottom, since we already have A that we want to go through. Let's label this one D down here. If we connect A to D, we have a perpendicular line that goes through that point. Exactly what we want to construct. And it might look a little messy, but if I delete these circles real quick, you'll see it. There we go. So here are the steps. Compare them with your own. And our last construction on this lesson with perpendicular bisectors is inscribing a square in a circle. Now, inscribed might be a new word for you. Inscribed means that literally written inside, scribed right and inside. What we mean with a square is that we mean the vertices are all on the circle and the square is entirely inside of it. So we kind of want to end up with something like, I'll draw you a picture real quick. It's going to look something like this diagram down here on the bottom. It might be rotated around, but notice how all the vertices are on the circle and the square is entirely inside it. That's what we're aiming for. So to do that, we're going to end up drawing the diagonals, actually, and that's going to get us the vertices. So first, zoom in a little bit, we're going to draw a diameter. Now, a diameter is just a chord that goes through the center. So use your ruler, line it up with the center of your circle, and there we go. So that is one diameter. Let's make it blue. And let's label the endpoints. Now we want to call this square ABCD, and we're going to label it clockwise. So let's call this one A. So if we went around, we'd have B somewhere over here. So C's got to be down here. Change where C is. So a property we're going to learn about squares. Well, we know square is both a rectangle and a rhombus. And in a rhombus, the diagonals are perpendicular to each other. So if we draw a perpendicular bisector here, we will have perpendicular diagonals. And another property, rectangles have diagonals which are congruent. And since we're drawing diameters here, the diagonals will be congruent. So we'll have a rhombus and a rectangle, and therefore a square. So take the compass, put it on A, and we're going to do the perpendicular bisector construction here. So open it up to C. Nope, me open it a little bit more. There we go. And let's do this one in red. All right, so let's draw that circle and do the same thing over at C. So don't change how big your compass is. So let's draw the perpendicular bisector in here with those points of intersection. I don't really need to label them right now because we only really care about the square. So I'm going to leave those unlabeled. You can if you want, you don't have to. And now, look at the points where the perpendicular bisector we just drew. Let's change that color. Let's make that one orange. Look at where the orange perpendicular bisector hits the black circle. Let's call this one B, and let's call this other point D. When we connect these, we will have our square. That was off a little bit. Yeah, let's move that over. That looks better. Oops. So I'm going to go ahead and connect those. Okay, I drew my square. It's got a little bit of a slant. Yeah, I'm off a little bit. But it will be a square. If I delete these construction aids, then you'll see that it's a square. It's tilted a little bit. And if you measure it, you should get the four angles being just should be exactly 90 degrees. With measurement error, it might be a little bit off. That's okay. And here are the steps for inscribing a square in a circle. Compare them with your own steps. And in this lesson, we learned how to make perpendicular bisectors and a couple other applications of them. Thanks for watching this video.